bringing cloud workloads down to the edge requires running containers down there and allows to do a lot of things, sometimes not always good things. And there are threats that needs to be controlled. Michael and Maneesh are here to tell us everything you need to know about Zscaler, which is a solution to lock down and secure outbound and inbound connectivity and communications with your edge devices. That's today on the IoT Show. Hi everyone, this is the IoT Show. I'm Olivier, your host, and today we will talk securing IoT edges. And for that, we have Maneesh and Michael. Guys, welcome to the IoT Show today. Let's do a little bit of introduction. Let's start with you, Maneesh. Who are you and what are you doing in life?
Oh, thanks, Olivier. Nice to be on the IoT Show. I'm the Senior Director of Product Management for OT and IoT at Zscaler. I'm here because, majority of our customers who also happen to be Microsoft Azure IoT customers want a way to secure traffic from Azure IoT Edges, as well as secure access into Azure IoT Edges. So I'm here with Michael. Michael, can you introduce yourself?
Yeah, hey everybody, my name's Michael Wheeler. I'm a Principal Field PM for OT and IoT Security here at Zscaler, and I am on Maneesh's team.
Well, thanks guys for joining today. So Maneesh, you are here to tell us about securing IoT edges, right? You already alluded to that, but tell me more about the need for securing connectivity for these devices.
Yeah, thanks. So before I get to the IoT edges and Azure IoT specifically, let me talk about the need for having such a proxy. And Zscaler was one of the first companies to introduce this concept where we built this big Zero Trust Exchange, which is essentially a switchboard in the sky. We are pretty much a proxy for all the traffic emanating from end users' devices. That's where we began our journey initially 15 years back. And then we expanded the footprint from devices to mobility devices like tablets and iPhones and Android phones, to sites and locations, moving to headless entities such as workloads. And now, over the last many years, we've had this strong demand to also secure traffic, both inbound as well as outbound from these IoT edges. And we do this at scale globally. We got 150 service edges. We have direct peering with some of the largest hyperscalers, including Microsoft and Azure. And our customers are asking us to secure those IoT edges very similar to how we do this for other end user devices. And the reason is because, with the introduction of edges and the ability for workloads to be introduced on these devices, today it could be Docker or containers or even Kubernetes, it's pretty much a wild west, and there's a possibility of introduction of malware and ransomware, which these customers want to prevent against.
Yeah, and as a matter of fact, you're saying wild west. I think there's one factor from my perspective at least, but you tell me if I'm right or wrong here. The world of this IT technologies, Kubernetes, containers, all of that is coming as super fast onto the operations world, right? We're seeing more and more of these technologies coming closer to the IoT infrastructure, and that's something that is new to people developing these more hardened devices. And now they are told, hey, we're going to get some workloads from the cloud down there on that device. So you need to secure all of that. So tell me, you have some data that actually shows what kind of a threat we're talking about here.
Yeah, definitely. And again, what we are seeing is an explosive growth in encrypted threat volume. So today, these IoT devices and edges are connected to the cloud gateways, such as the IoT Hub, on an encrypted channel. It could be AMQP, it could be WebSockets, and these are all encrypted. But that has actually weaponized some of the bad actors. And today we have solutions such as Microsoft IoT Defender, which allow you to do scanning of firmwares and modules before they can be over-the-air updated on your fleet of devices. But what our research team has seen is there's a increased amount of mal activity on this encrypted channel, and these cannot be detected at static compile time or code delivery time. What we are seeing is this advanced evasion, this delivery exploitation, command and control, and Zscaler today blocks about 6.6 billion such threats, and we're seeing majority of them over these SSL channels.
Wow.
In fact, the majority of the customers who are impacted on this are in the manufacturing, healthcare, technology, which are also, the locations where these Azure IoT Edges are deployed.
These are not good numbers, right? And we always talk about, securing IoT is key, is important to the development of IoT actually, and to the fact that, people want to get access to that data to extract insight, take action, transform their business. But seeing that, yes, I understand why people are scared of connecting these assets and devices. There's something to say as well about the fact that sometimes these assets are not super recent, right? They are equipments that have been offline for some time, and now they're getting online, right? And so there's something, they've not been designed for connectivity or for being online all the time. And so that's an interesting set of data. How is Zscaler addressing these threats, and what is the solution looking like?
Yeah, sure. So I want to talk about two of our solution offerings that we have for IoT Edges. One of them is for securing the outbound traffic to make sure there's no kind of a supply chain attack, no introduction of malware onto the edges themselves. Mm-hmm. And the second one, which is more of an additional functionality which we have opened up, is the ability for somebody to remotely connect to these devices securely without the need of opening up any ports or making them available on the internet, and securely allowing access to those devices. So the first one is the outbound traffic, and I'm going to pass it over to Michael, who's going to be talking about our secure internet access.
Yeah, thanks, Maneesh. So this slide is a little bit simplistic, but it shows the general idea. So we have IoT devices out in the field, and we are relaying that data via the IoT Edge back to Azure IoT Hub. So that's the general flow. And with Zscaler in the middle here, the idea is for Zscaler to be the broker for all of your traffic. So whether it be edge to internet, internet to edge, we want to have all of that traffic come through the Zscaler cloud. And getting the traffic to the Zscaler cloud is a pretty easy process. We're pretty flexible with how we can get the traffic there. So if the IoT Edge is in a controlled environment that you control the network, then you can build a tunnel to Zscaler from either a firewall or a router. We also have a component called branch connector that can be deployed on premise to on-ramp the traffic into the Zscaler cloud. Now, if these IoT edges are in the field where you may not control the network that this IoT edge and everything behind it is sitting on, then we can also deploy a container directly onto the IoT edge, and that will on-ramp the traffic to the Zscaler cloud. So just realize that getting the traffic to the Zscaler cloud is the important part, and we're pretty flexible with how we do it. Now, once we have the traffic in the Zscaler cloud, we can apply some of those protections that Maneesh was talking about earlier, and I believe we have that on the next slide. So a little bit about how the Zscaler cloud solution works. So from the network's perspective, we are a full TCP and UDP proxy. And so for those of you that have a networking background out there, that means that as the TLS connection comes into the Zscaler cloud, we terminate it, open and inspect it, and then start a new TLS connection on the backside. And that actually applies for all connections coming through the Zscaler cloud, not just regular TLS connections. So once the traffic is leaving the IoT edge, it will come to the Zscaler cloud. And the important thing to understand about the Zscaler cloud is that we are a full proxy. So we terminate the connection as it enters the Zscaler cloud. We do all of the analysis, everything from layer 3 all the way up to layer 7. And then we start a new connection egressing the Zscaler cloud as it goes to random sites on the internet or even to the Azure IoT Hub. So we have a load of information available to us, and if we are able to install an SSL certificate onto the IoT Edge, there are even higher level functions that we can use to protect this traffic. Now, the traffic going from the IoT Edge to the IoT Hub is already secured by TLS, so we assume that to be relatively secure. But we also have to accommodate for the fact that these IoT edges may be running additional containers that reach out to other places on the internet. And so the next slide will show what we can do with that traffic once we have the ability to open and inspect it. So all of these features here that are listed are core functions of the Zscaler cloud and the types of protections that we can apply to that traffic. So if we think about situations like supply chain attacks, where the container downloads another container or downloads additional code, we can run that through the Zscaler cloud and do things like URL filtering to make sure that things are coming from appropriate sources. We can do malware protection to make sure that traffic is not malware. But we also have the ability to do some additional really cool things like advanced cloud firewall. So we can do layer 7 firewall with IPS and even DNS inspection to protect against all different types of attacks that may be, even if you do compromise that IoT edge, all of the traffic is going to be going out to the internet via the Zscaler cloud, and we can protect that traffic to ensure that even if the IoT Edge is compromised, it's not going to be able to call home to its command and control server, or nobody is going to be able to remotely access it.
Interesting. So I was about to ask you, Ashley, why would I need to use Zscaler if I have IoT Edge, which already secures over TLS that connectivity? But you just explained that really well. All the things that can be done once you have a container orchestrator at the edge, it's a wild, wild west, right? Like Maneesh was saying earlier on. And so you need to be ready and secure for all the things. So I can understand that way better now. Thanks for that clarification here, Michael. So Maneesh, you have a demo for us. Let's jump into that demo and see how things are working.
Yes, definitely. So what I'm going to now do is bring up my browser and show you a SSH session into this one of such IoT edges, which I have in my lab. It's a Percept Dev Kit. And I'm connected here. And I want to show you the kind of protection which we can layer on top of what Microsoft provides. So I'm going to allow a list here with saying that if it's going to any of the Microsoft IoT Hub destinations, allow it. And we build this allow list. It's configurable per location. But I also set up a policy saying that if any of the containers accesses some of the crypto mining websites, then you block it. So I'm going to simulate a similar REST call, which is pretty much what any container which is doing crypto mining does. So it's going out to a known location, which is known for the cryptojacking. And when it tries to connect, this is blocked, no route to host. Why is this? Because it was sent out to Zscaler. Zscaler said, nope, this IoT Edge was not designed to be handling this. It could be, but in this scenario, it was not. And as a result, it was blocked. However, if you go to some other website, like say bing.com, then you get the full information. So this is our solution for allowing and disallowing traffic based on destinations. We can have advanced threat protections. Another situation is the data exfiltration attacks.
So Maneesh, let me ask you real quick here. So is it based on whitelist, blacklist type of configuration, or are you Zscaler providing this kind of list to customers? Do they have to build their own one, or are you helping them as well in there?
Yeah, great question. We actually have built an entire list of such categories of sites which are deemed good and bad, and we categorize it based on these sites which are meant for crypto mining or known malware attacks, known command and control attacks. And actually, let me show you one other aspect. So as the traffic flows through our cloud, we are able to see exactly what is going on. So if I switch over the logs and apply the filters, you can see all the traffic which is emanated from this edge One of them happens to be that call to XMReg, which is that crypto mining, and this was blocked. Well, everything else, which is going to Docker and maybe some private Zscaler, and one of the containers on this edge happens to be a remote access container built by Zscaler. I'm happy to show that to you at some point.
Yep.
But you can see exactly what's going on from this edge. So you can use what is available today, or you can constrain this further, looking at all the activities going on out here.
Nice, nice. So you have this log and you can build your own lists and your own understanding of what's going on based on that list. Perfect, love it. So you were saying that you used kind of casually that tool that was about remoting into a device, and that's something that is problematic for a lot. People are used to be able to access their Linux VMs or machines or Windows machines and so on remotely. And for that, they need to have remote access. But once you're securing things, you're behind a firewall, you're in an enterprise network or an industry network, you can't, right? Because that's something that is not secure and safe. Or you have SSH, but you need to provide credentials, passwords, and username, and that becomes a real nightmare. You have a solution for that. You just alluded to that. You casually used it. Let's go back to that remote access tool here that you have.
So this brings me to the second solution area, which Zscaler provides, which is the secure remote access to the edge itself via SSH to Linux-based edges, or to any downstream devices which this edge might be connected to already. And this is, again, a solution which is being used by many of our common customers. One of them happens to maintain oil rigs across the entire world. And what they found was they already had an edge which was pulling information using any of these protocols like OPC or Modbus. But they were having a really hard time maintaining it, triaging problems or troubleshooting it, because these devices happen to be on rigs in the middle of the ocean, like the Gulf of Mexico, probably connected using satellite connections. And in order to triage a problem, the only other option was to fly somebody on a helicopter onto the rigs. So they looked at us for providing this solution where we were able to Dockerize our remote access solution and put this on the edge. We have this container on ARM64 and AMD64 architectures, and they were able to run this as another module on this Docker container, all managed through Azure IoT Hub. And using the policies in ZPA, which is Zscaler Private Access, our remote access solution, allowed to only access the SSH service, which is running on the edge, only locally. So the important aspect is no open ports. The SSH is only allows local connections. It's not something which you need to publish on the web. So you go to Shodan and this edge is never going to show up on any of the results. We keep this hidden from everybody else. And the only way people get in is through a Zero Trust Exchange, where they first need to authenticate with an identity provider. They might use Azure AD, they might use Okta, they might use any other identity provider. And once they authenticate themselves, we can apply policy. It could be, hey, are these employees remote workers, or are these third parties who've been paid to troubleshoot a problem with the specific machinery on the downstream devices? And once we allow that, we allow this remote connection. So if I were to switch back and go back to my browser and go to this particular area, actually, let me turn this off and I'll show you this full experience about what this entails. So
and you were saying you're in the browser, so you don't even need to have a client to do that.
Exactly. So let me log out and let me log back in. So all you need to do is point to a particular endpoint, usually a company, let's say acme.corp.com, which is a famous Microsoft customer. They would publish something like portal.acme.corp.com. And the first thing they would be asked to do is authenticate. And you would generally register your identity provider and federate it using either SAML or use SCIM. So, and then the end user would need to authenticate. So they would use the corporate email address. acme.com. I'm here using Lisa Zero Trust Exchange. And we click on sign in. It's gonna actually forward to the identity provider. I'm already logged in to the Azure AD. And now when it redirects back to the portal after authentication, you might use multi-factor, biometrics, whatever. The users are authenticated, and now they see a bunch of tiles out here. And one of the tiles happens to be the Azure IoT Edge, the Percept Dev Kit. And when the end user clicks on it, they are now provided this tab with a canvas, which renders it as a session as pixels. So this is really great because there's no possible way by which any malware can be introduced. If we look at Mirai, it's constantly scanning for nearby computers. There's no way this is going to be accessible by Mirai. Okay. Now, you can use the same command. So you and just like you would interact, you can use your local keyboard or your on-screen keyboard, and you can get logs. You can see, what the downstream devices are doing, and more often than not, folks need to be uploading some particular configurations, and again, that can be enabled or disabled based on policies. And this policy, I've allowed uploads. So I'm going to show you what might happen if somebody tries to upload a particular file. So here, they need to upload some file for a downstream device. It's a Linux ELF file. And when they attempt to upload it, you can see that by running this to a proxy, we run this through what is called Advanced Cloud Sandbox, and we notice that this is actually got malware on it. We could get existing signatures and hashes from partners such as Microsoft telling us, if you see such a file like this, that should be blocked by default. But in this case, we can also protect against patient zero attacks, where it's a new kind of malware, and we can exploit this in a VM, see any behavior which it is doing, like reaching out to other internet destinations, writing registry entries in the case of Windows executables, writing to a file system. And once we deem that behavior is kosher, we give it a thumbs up. In this case, our sandbox gave a verdict that there's something problematic with it, and therefore prevented this upload. On the other hand, if there was a legitimate file like this existing XLS file, and here we go, it runs through the sandbox, and voila, you now have this available for it to be utilized on this edge. Nice. So now you have completely secured access, interactive, as well as file-based uploads to this destination.
Yeah, and I can imagine the phone call you're going to get, because lots of people who are admins or need to manage and operate these kind of devices, they need to have this level of control over what people can do, not just, opening, everything, all the faucets and so on for everyone to do whatever they want. Here you have fine control when you're administering, when you're managing and operating this kind of devices. Maneesh, Michael, great overview, because there's way more to talk about Zscaler, but we don't have to have today. What is it that you would recommend our viewers to do next? Now they're interested and would buy at least the ZPRA tool and all the rest. So what do you recommend they do now?
All right, Olivier, so we got this microsite which we have published. It's called Secure Your OT and IoT. Okay. The URL is listed here. I would urge folks who are viewing this to go to the website, see our solution briefs, or contact our team and get a deeper dive.
Awesome. Perfect. Well, thanks a lot for your time today, both of you. I hope to see you soon back on the IoT Show, because you have super interesting solutions for securing IoT devices, IoT edges, like you're saying. I like this term. Well, see you soon, guys. Thank you. Bye.